The content of this presentation on cleanroom measurement methods for verification and monitoring is particle counting, where we talk about particle counter, particle size distribution, classification and monitoring. And on particle deposition monitoring, where we talk about the principle and type of instruments. And at last, surface cleanliness measurements on direct and indirect measurement methods. A particle counter measures the particles in air. It takes an air sample into the measurement system, and there a particle will pass a laser beam and scatter light. This light will be collected through a hollow mirror onto a sensor. So a particle will produce a voltage peak. And this voltage peak can be compared with the voltage peak given by a known particles, a particle which you use to calibrate this instrument. Normally, a particle counter is calibrated for a number of particle sizes, and when you're measuring, the particles are just put into particle size bins. So particles between size A and B, particles between size B and C, and so on. And this distribution we call a differential distribution. And later I will explain how you can make a cumulative distribution of this. So with a particle counter, we measure the concentration, which is the number of particles per cubic meter. Often these counters, they measure per cubic foot, but we recalculate it into a cubic meter to be able to compare measurement values with ISO standard limits. The number of particles per cubic meter is found by taking your sample time, your measurement time in minutes, and multiply this by the sample flow in liters per minute or in cubic meters per minute. So the concentration of particles within a particle size bin, let's say N A to B, divided by time and flow. I've given a small example here where the number of particles we counted between A and B is 35, the time 3 minutes, and the flow in cubic foot per minute are 28.3 liters per minute. If we calculate this, then we'll find the result of 2 particles per liter air, or 2000 particles per cubic meter. In a particle counter, you can have more size bins from A to B, from B to C, from C to D. I have another example in the table below where I've put A at 0.3 micrometers, B at 0.5 micrometers, and C at 1 micrometer, and D at 5. Then on the left hand side you see then a table where we have the particle size bins and the number of particles per cubic meter. And on the right hand side you can see how we calculate a cumulative distribution from that. We start with the number of particles larger than 5 micrometers, then we add the next particle size bin, and then we add the next one and the next one, and that way you get a particle size distribution which we normally use when we talk about air cleanliness. So we can talk about the total number of particles larger than 1 micrometer. When we want to classify a clean room, we have to follow a procedure which is written in the ISO standard 14644-1, which is published in 2015. The starting point is the area of your clean room. You take the area in square meters and you go to the table in the standard, and that gives you the number of sample locations you have to take for this room. Then you divide the room in a number of sections equal to the required sample locations. So when you have drawn the sample sections on your clean room floor, you can determine one measurement point in each section. Then it's important to know in which state of occupancy you are going to measure. As built, when the clean room is just being built, or at rest, when there are no people in the clean room but all the equipment is there, and operational, when you use the clean room when you produce your product or run your processes. Then you determine the particle sizes, mostly one particle size, but you could take two, which you want to use for your classification. This particle size should be within the table of the ISO standard and is also within 0.1 micrometer and 5 micrometer. Then you make one measurement at each location, or you take more measurements and you take the average value. A measurement should be at least 1 minute and should sample at least so much air that you can count 20 particles when you are within the class limit. The highest measured value of all the different sections determines the cleanroom class. A particle counter can also be used for monitoring. Monitoring we do at a critical location. We measure the particle concentration during time at different moments, continuously or each day, each week, each month. How often you do it and where you do it is determined by a risk assessment. So you use a risk assessment to determine a critical location, critical moments, and that information you use to make a monitoring plan. And in the monitoring plan, there you set your measurement times, your measurement frequencies, your critical locations, particle sizes of interest, and you can set action and alert levels. When you do real-time measurement, then with a particle counter, you can really see the activity of personnel inside the clean room. The other way of looking at air cleanliness is by monitoring particle deposition. Particle deposition, you also look at your critical locations which you have determined by risk assessment, you make a monitoring plan, and then you measure particle deposition by the use of witness plates or test surfaces in a sensor. You measure the surface concentration before and after the sampling time. When you have a witness plate, you have to take it carefully from your location to a sensor to measure the particles on the surface, but if you use a sensor, the sensor can do everything and you don't need to interfere as a user. We measure the differential distribution over the time of interest, and normally we only look at the time during operation. From the differential distribution, like I explained with the particle counter, you calculate again a cumulative distribution which gives you the number of particles per square meter or per square decimeter per hour. And from there you can determine your particle deposition rate for your critical particle size D. So there are two types of particle deposition rate instruments. You have the instruments which use witness plates that can be placed in many locations inside the clean room, and you have instruments which make use of sensors. Here you see three examples of instruments that can measure the particles on a glass witness plate. The profit of this approach is that you can measure many locations at the same time. The drawback is that you have a risk of disturbing your measurement results, because when you pick and place your witness plate, particles can come off or drop extra onto the witness plate, and it's a very labor-intensive procedure. So especially when you know your critical locations, it's best to use a sensor, because then you can do real-time monitoring. Mostly with a real-time monitoring you have an online capability, so that you don't even need to go into the clean room to have a look at the results. Within Brockhaus we have the Upmont system, which is shown at the left side, but there are also other instruments on the market using slightly different measurement principles. When we measure particle deposition, we look in fact at the change of surface cleanliness. I have to explain that when we look at a particle onto a surface, we see the silhouette of a particle, and we take the largest dimension of this particle to to determine the size of the particle. We recalculate the differential distribution into a cumulative distribution, and in fact we monitor the change of surface cleanliness. In some cases in the clean room you want to measure the surface cleanliness of a product, of a part, or a tool, or a workbench. There are different instruments to measure the surface cleanliness directly. You can do this under a microscope or a surface inspection microscope, with which you bring your microscope onto a surface, but mostly they measure only a very small area. You can also do it qualitative by using a bright light or a UV light, which shows you the particles on a surface. When we look at microscopes, there are two ways to use it. When you are interested in slightly larger particles, a stereo microscope is very useful. If you really want to look at very small particles, you need a professional microscope. Large surfaces, unflat surfaces, complicated shapes are very difficult to measure directly. In that case, we try to remove the particles from the surface into another medium, into air, liquid, or onto another solid surface. The first method we can use is air. You take a probe which you put onto the surface, you blow air, and then you take that air into the particle counter, and the particle counter can then measure the particles which are released from the surface. It is also possible to suck air over a surface and collect the air through a filter, and then you take the filter and examine the particles which are filtered out of this air under a microscope, and then you calculate the number of particles back to the surface you have been testing. The second method is with liquid. We wash the object in a liquid, sometimes with a little bit of mechanical force like spraying or a little bit of ultrasonics, and we try to remove all particles into this liquid. Then the liquid can be filtered and particles can be counted onto the filter, or you can measure the liquid directly using a liquid particle counter. And the third method is taking a flexible solid material, a flexible rubber, because a rubber can shape itself around a particle and pick particles from a surface, and then you can inspect this pickup rubber under a microscope or another measurement instrument which can detect particles on the surface. Thank you very much for your attention. Our next video will be on air cleanliness.